Okay, let's try a word problem. A slight variant on our pen building problem for our bunny. We have some pen that we're making that has a certain length and a certain width, and we're told that it's longer than it is wide, so the length of our pen is 2 more than the width. Whatever our units, let's say this is all in feet. So the length is 2 more feet than the width. And let's say the total area for our bunny in our pen with a floor that for some reason the bunny can't burrow through is going to be equal to, I don't know, let's just pick a number 20. I'm picking 20. Okay, what are the dimensions? So I want the length and the width. So what do I want to find? I want to find both L and W. Let's write that down. And what do I know? Let's write down everything that we're given in the problem. Well, the length is 2 more than the width, so the length is the width plus 2. And I know that the area is 20, but what is area? Length times width. So LW equals 20. Now, I have this. So how do I solve this? Well, maybe I don't know how to solve this, but I have some stuff, and if you don't know what to do in a word problem, quite often plugging is not a bad thing to consider. So let's consider that. I have an L right here. So I get W plus 2 times W is equal to 20. Or I get W squared plus 2W minus 20 equals 0. So if I can solve this equation, I'm boxing it, but I'm not done yet. I want to solve this equation right here. I know if I solve it, I'll be done with the width, and then I can use the width very quickly to get the length. Okay, so how do I solve this? Well, I could try factoring numbers that give me 20 that somehow are 2 apart. Well, no, 1 and 20, 2 and 10, 4 and 5. Doesn't seem like it's going to work. So let's just try using the quadratic formula over here. So I'm going to do what I did last time. I'm just going to compute that discriminant first because I need to know it anyway. By the way, the formula, and I'll just rewrite it over here, negative b plus or minus the root of the discriminant. Okay, let's plug. So what am I going to get? I'm going to get negative 2 because A is 1, B is 2, and C is minus 20. So I get negative 2 plus or minus B squared minus 4AC over 2A. I said I was going to compute the discriminant first. I probably should have. I didn't. That's fine. We'll just keep going because this is going to give me 84. 20 times 4 is 80. It's positive 80 because I have 2 negatives. So I get 84 minus 2 plus or minus the root of 84 over 2. And what do I happen to know about 84? Well, is it divisible by, I don't know, is it divisible by 4? That would be nice because then I could pull the 4 out and make it a 2 and everything would simplify. Not everything, but I'd get a fraction. I'd get one less fraction in the problem. I'd still have a root. Well, it turns out that 84 is divisible by 4 because it's 4 times 21. So I get this. And then that gives me this, which is Well, when I'm done, minus 1 plus or minus the root of 21. So, I have two solutions. Or do I? Is it possible for my length or my width to be negative? No, we don't want to crush the bunny. Maybe there's some weird negative space, some parallel universe that the bunny gets sent to if I have negative length or width. I don't know, but to keep this problem in the real world, I want positive length and positive width. So, what am I going to do? I'm going to throw out one of these solutions because it doesn't make any sense for real life. I'm going to throw out minus 1 minus root 21, and I'm just going to keep minus 1 plus root 21. That is my length. Okay, what do I know? Remember that the length is the width plus 2. So if this is my, this is my width, because we were computing the width. So my width is minus 1 plus root 21. So now I want to find the length, knowing that the length is the width plus 2, it's this plus 2. Well, if I add 2, I just get minus 1 plus 2 plus root 21. So, here's what I'm going to do now. We did a lot of computation. What happens if I actually have a pen with length 1 plus root 21 and width minus 1 plus root 21? Let's see. Am I actually going to get an area of 20? Because we said we needed an area of 20 for that bunny. So, let's multiply. L times W. By the way, we're checking our answer now. This is the answer. I want to check it. I want to see if my length times my width actually gives me 20. So, is it true that this times this equals 20? Well, let's see. I get minus 1. This is going to be the negative of this. I'll write it out. So this is going to be root 21 times negative 1 plus 1 times root 21. Those cancel. And then finally, I get plus the root of 21 squared, which is 21. Minus 1 plus 21 gives me 20. So that is me checking this answer, and we know now that our dimensions are correct. That is what gives me the area that we needed. So that's an example of using the quadratic formula to solve a word problem.